Let's consider this surface that depends on x and y. Now let's say that for whatever reason you want to calculate the limit when this function goes to x, y, 0, 0. We already know that this means calculating the limit when x, y go to 0, 0 of x cubed y over x to the power of 6 plus y to the power of 2. Just like before, a way to try to calculate limits to begin with is to plug in the values and see if you get a number. If we do this, we end up with 0 over 0, which is undefined. The problem in this case is the likelihood of this limit not existing is actually quite high. And because of that, your probably best bet to solve this is to show that the limit does not exist, which is way easier than showing that it does and calculating it. The way you can do this is to calculate the limit along a specific path. Say a path where the relation y equals x is valid. What does this mean? It means that for this specific path, as you approach point xy 0, 0, you'd be calculating the limit and x, y go to 0, 0, and all you're doing is where you have a y, you're replacing it by an x, which means this becomes x to the power of 4, and on the bottom you get x to the power of 6 plus x to the power of 2. And if you remember anything from limits, one of the things you can very easily do, this is still undefined, this would be 0 over 0, but you can divide by x over 2, which means this would be the same as calculating the limit when x, y go to 0, 0 of x to the power of 2 over x to the power of 4 plus 1, which means this would be 0. Is this telling you what is the value of this limit? No, it tells you what is the value of the limit along this direction when you approach xy along y equals x. So what you do next is you take another path, say y equals x to the power of 3, and you repeat the same experiment. In this case, you're taking limit when x, y go to 0, 0, and when you have a y, you replace it by x to the power of 3. You end with x to the power of 6 over x to the power of 6 plus x to the power of 6. You divide by x to the power of 6, and this means the limit when x, y go to 0, 0 of 1 over 2. What is this telling you? Clearly 1 over 2 is different from 0, and therefore the limit does not exist. And in most cases for these functions of more than one variable, when it's not clear or you don't know that the function is continuous, better than trying to calculate the limit, which probably doesn't exist, is to calculate the limit along different directions and to show, like in this case, that the values are different, and this implies that the limit does not exist. And you can even see this visualization here done in Topcat of the function in the vicinity of the point, and you can see why the limit doesn't exist. The function definitely is not continuous, and it's behaving very, very weirdly in the vicinity of xy equals 0, 0. Having showed this plot, I think we're definitely ready to visualize surfaces and looking at the equations given by them, and also to test out Topcat and to use the grid that I provide to you.